Hello, hello. This is Irene with SaugaTalks. Hello, everybody. Thank you for tuning in. Thank you. If you're not following SaugaTalks on LinkedIn, on Twitter, if you're not subscribed to YouTube, please do it now, all right? Just to get it out of the way. I speak with fascinating people in tech here, all right? And we discuss artificial intelligence, data science, metaverse, automation, bunch of incredibly hot topics right now. And today, my guest is Suraj Gajendra. Suraj, how are you?
I'm good, Irene. How are you?
I'm doing incredibly well because guess what? The topic we're going to talk about today is all about enterprise and strategy and increasing performance and really helping companies out there to survive and thrive in this economic landscape. Technology is a unicorn. Okay,
Yeah,
in a lot of
yeah,
ways, technology is driving changes in business nowadays. All right. So, can you talk to us about state of AI today in 2023, meaning widespread adoption and what's for us in the future?
yeah. I mean, I think thanks, Irene, by the way, for this opportunity. So it's great to be with you. I mean, I've watched some of your videos, and they're really, really thought provoking. You talk to some extremely, extremely intelligent people out there. So the work that you're doing is fantastic. So and thanks for inviting me. So I feel that we are at an inflection point in the journey to autonomous, right? So that's what I like to call it, journey to autonomous. Yes, there's been a lot of experimentations over the last few years, but I think we are at a point where we kind of are seeing new applications being developed based on AI, right? So we are not yet there where we can even remotely say that artificial intelligence can be on par with human intelligence or whatever. I mean, there's still a lot of work that we need to do in general. Maybe the generative AI stuff that you see these days, or maybe autonomous cars, for example, right? So there's still a long way to go, but I feel we'll eventually get there, right? And we are making some rapid progress in that space. So I think for AI to get broadly adopted across different industries like healthcare or manufacturing or banking, financial in general, I think we need to kind of have a couple of fundamental steps that we need to take. One is we need to collectively build a broad, open, flexible ecosystem of hardware, software tools, and applications across the industry, so which can enable data scientists, data engineers, or even AI developer community to be able to innovate on, right? So this is work in progress at the moment, and I will talk more about it, right? And on the other hand, the accuracy of any AI model, basically relies on the data that it gets fed on or trained on. So any new data set, or either that is not digitally documented, or not the models doesn't have access to, can't be used for training. So there will always be this barrier about, okay, what data is available for training, right, for the models to kind of work on, and what is not. So and that's what you can also look at it as like a barrier for for AI to kind of get as close as possible to the human intelligence. But also that's where more innovation and more work is actually needed for us to kind of enable the availability of data, the accessibility of data for us to have better AI models.
Absolutely, absolutely, Suraj. I'm glad you brought this up because one thing is to start an experimentation with AI, right? And most
Mhm.
companies kind of at this stage. What about scaling? Okay, is it easier? Is it cost effective? Is it better for companies out there these days than comparing, right, a few years ago?
Yeah, I mean, great point, right? I think, see, fundamentally, Irene, what I feel is, again, before we talk about scale, let's just understand who are the players in the space, right? On one front, you have hyperscalers, cloud service providers, or AI research companies like OpenAI, for example, just pushing the boundaries of compute with their innovation in large-scale models and enabling massive AI-enabled applications. I mean, based on large language models, for example, or diffusion models that you actually see. So for them, it's really the value that they are actually trying to extract is optimized models, how better they can actually make those models, how accurate they can actually make those models. And their expectations from a scale perspective is availability of performance systems, right? I mean, I'm not just talking about hardware, but software infrastructure and all of that stuff, ease of use, right? And reduced operational cost and and power, right? I mean, that's we're all talking about green AI, we're all talking about climate change. So it's very important for all of these large scale people working on these large scale models to fundamentally kind of ensure that the computation that they do is actually done efficiently at a very power optimized way. So that's one class of players, right? So, and then there is the other class of players with enterprises, for example, right, who would want to kind of make use of applications based on these models that are trained. So for them, the scale is really kind of like enabled through ease of use, right? So you're talking about companies like who are in the healthcare business or financial or industrial or automotive, who basically there's abundant amount of data available, right? Now they need to basically figure out how can they use the data and build accurate models, or or use pre-trained models or fine-tune those models and build much better efficient productivity tools for them, right? In order to kind of like improve the effectiveness of or even enable new services. So for them, the key thing is ease of use, right? So they want to be able to kind of like say, okay, can I get a platform which has the hardware, which has the right amount of software, the tools, and everything that they can actually take and just work on data analytics, right? So I think it's, again, depends on whom you talk to when you think about AI scale, and for enterprises, I truly believe that it's our responsibility. When I say our responsibility, people who are enabling the AI hardware, people who are enabling the AI software tools, and even people who actually work on large scale models, it's our responsibility collectively to ensure that there is open, flexible platform for data scientists in enterprises to basically work on and build on, right? So that's the way I basically see scale.
As we see, organizations accelerating development across many workloads, right? Across their complex IT landscape and bunch of legacy applications, right? And their new AI and data analytics apps. How do we see the AI is developing from life sciences to finance to academic research, all these complex models being developed, as you mentioned, but at the same time, what role technology companies will be playing? Intel is one of them, of course. So could you please show us the way, what's changing today, this year?
This is it's like I told you, we're absolutely at the inflection point, right? I mean, we can exponentially grow our AI capabilities across. I'm talking about not just Intel, I'm talking about the whole industry as a whole. But we got to do the right things. And one thing that when it comes to organizations, when it comes to enterprises, one thing that I want to establish, it's beyond just AI benchmark, right? It's beyond, okay, what's the performance of a specific type of hardware for a specific benchmark. Because when you think about enterprises, as I told you, it's a pipeline. It's an AI pipeline that they're looking at. They're looking at data prep, right? There are different steps in data prep. So that's the number one step. That you can think about data collection, you can think about data ingestion, labeling, validation, all of those pre-processing that needs to be done at the data level. So that's one aspect, right? And then you have the model itself. I mean, it could either be model creation, depending on what sort of data sets you're actually working on, or you're basically kind of like looking at, fine-tuning an existing model, or retraining an existing model, right? So it's really about enabling the right models and optimizing the models for your application, right? And then finally, it's really about the deployment, right? So it's data prep, it's model creation and model optimization, and then deployment. So all of these three steps are important, right? So all of these three steps, I mean, so that's what I'm telling. It's for enterprises, it's kind of like a pipeline. They don't look at it as, okay, this is, okay, my platform or my use case is actually kind of like is going to perform absolutely perfectly if I get this one particular AI benchmark, number right. So it's beyond that, right? It's about this pipeline. So I mean, I think so when you think about it, right? So it's it's important for technology companies also. So let's just unpack this for a second, right? So you have, even in this pipeline, you have at the lowest level, you have hardware, right? So there's hardware selection. So depending on your application, you either kind of like are using CPUs or a bunch of CPUs, or you basically have a CPU plus GPU, for example, or accelerator, for example. So you need to have specialized hardware, right, to some extent, in order to kind of enable optimized AI computation. And equally important is this middle layers of software tools and libraries and frameworks and ops and all of those infrastructure that needs to be enabled in order to kind of like make development of applications on top across, say, data prep or model creation or deployment as easy as possible. So that's that's key, right? So often what happens is, today, to some extent, like technology companies or hardware companies basically enable the hardware, right? And then there are, massive software companies, ISVs, for example, who are actually working on different tool sets. Now, it's really kind of like critical for us as a community to come together and create that open platform, right? That can aid, data scientists sitting in enterprise companies through the pipeline, right? So, okay, optimize a platform that's actually optimized for data prep, the same platform that can actually be, used for model creation or model optimization, and the same platform that can actually be created for deployment, right? So one example, and the stuff that we are actually working on. So we recently launched the 4th generation Xeon scalable processors, right? Codenamed Sapphire Rapids, as you may know. So. And when I go back and talk about specialized hardware for AI, so the 4th generation Xeon scalable processors actually have specialized accelerators inside integrated within those CPUs to do like advanced vector or matrix computations. So what it essentially means is you can actually do a reasonable amount of training. You can absolutely do inferencing, right? So going back to the pipeline that I'm talking about, the Xeon processors can actually be used for data prep, right? So you can actually kind of, do all of the steps that I just highlighted in terms of data steps using the right tool sets. You can actually do the model creation. So it's the same platform that can actually enable model creation, right? And then you can also basically do the deployment, which is largely inference, right? So it's important for us to basically think about, again, from an end user's perspective, who is sitting in any of these vertical businesses that we talked about, and see how can we enable the software framework? How can we make it easy for the end users to just not worry about which hardware I have to actually enable? How do I, pick which software tool from which area and things like that? But just focus on, okay, here's my data set. This is what I want to get to. Can I get a universal platform that can help me, right? So, by the way, again, we have some ways to go there, right? And I'm just talking about CPUs right now. I just gave an example with just CPUs, but AI is a heterogeneous workload, right? So you need the CPUs, you need accelerators and stuff like that. But it's very essential for us to basically focus on this platform view, right? And that's what companies like Intel and others are actually kind of working on right now. And hopefully we'll kind of like solve those problems, some of these problems that the data scientists are actually kind of facing today. And that's our goal.
Why don't we talk about more AI applications, for instance, right? Responsive smart assistants, okay, chatbots. Everyone talk about chatbots nowadays, right? And now predictive text and language translation. There are a bunch of applications that mounting every day, right? And of course, natural language processing is taking the central stage. So what are the way to enable those technologies now? Again, with ease of use, of course.
Yeah, so I'll touch upon 2 points, and I want to stress upon some of the things that I just mentioned also, Irene, is again for say chatbots, and you talked about responsive smart assistants is what you said. I think again, 2 things that actually comes to mind is accuracy and latency. Okay, so the chatbots or any responsive smart assistants basically you need to, you want it to be accurate, right? You want it to be kind of, as accurate as possible, right? And the other, on the other side, you need to be, you want it to be as quick as possible. There should not be too much of lag, for example, right? I mean, for example, if you go on ChatGPT today and type a question, you want it to be kind of like responsive in like 10 seconds, for example, right? I mean, you can't wait for 2 hours. So the thing is, on the accuracy front, it's really about model optimization, feeding the models as large data sets and as good data sets as possible. So it can train on them, right? So you can actually kind of like enable large scale training and create as much accuracy as possible. So again, even in this one, right, it goes back to, as I told you, you need to be able, again, by the way, one other thing that I wanted to highlight was the amount of compute that's needed for these large scale models, for chatbots to work like the way they do. It's humongous, right? So the hardware technology is not really able to keep up with the requirements in terms of flops and in terms of massive data transmission bandwidth and stuff like that. So hence you kind of like see the whole compute getting distributed, right? So you run these large scale models on hundreds of hardware nodes, right? So so what happens is then it becomes efficient for you to connect these hardwares in a very efficient way. You need to have very reliable and robust networking. You need to have you can't kind of like have drops in data bits and stuff like that. So in addition to all of the specialized hardware, you also need to have this infrastructure where you can have reliable networking. So that's one aspect, right? And again, to build accuracy, you need to have better software tools. You need to train using the right software tools, and those software tools needs to basically extract out the right features from the hardware. Needs to basically enable the right features that the hardwares have. So so those are all important, right, from an accuracy perspective. And on the other hand, on the latency, for example, I mean, you need to, so that's where the inference comes, right? I mean, you need to have competitive inference technologies because, when you compare A versus B and you basically say whether it's pass or fail, I mean, you kind of, you're much more, you've got to do that at a much more, time sensitive way, right? So, for example, I mean, the Sapphire Rapids processor that I was talking about, I mean, has features like advanced matrix extensions with bfloat16 and int8 data type supports, which our framework has optimized for, right? Which means that you kind of like any inference models that actually uses these data types, you actually can get much better accuracy and latency, right? So we're also, by the way, working with a lot of ISVs. A lot of independent software vendors. For example, Hugging Face is one of them, where we're integrating Intel optimized libraries to their backend and partnering on solutions like Optimum that they have. So there is, again, going back to the point that I was making, it's really kind of like building the right infrastructure, both in terms of hardware, having the right feature set, supporting the right data types, and having the right software tools. That's important for us to kind of make these chatbots as smart and as responsive as possible.
Yep, Suraj. You mentioned multiple stakeholders, all right, and we know that AI experimentation and AI delivery and AI scaling becoming more and more collaborative effort, all right. So could you talk to us about cloud-based machine learning? Collaborative now, because again, more and more people, right, getting expertise in this. It's not those ivory tower data scientists with PhDs anymore, right? You absolutely have to democratize technology now.
I think so. You bring up a very good point. I think it's as there is a lot of, I don't want to quote percentages because different people have different perspectives around this, but I think there is massive amount or majority amount of AI development, AI software development, and application development, as you said, happening in the cloud, right? And I mean, guess what? So the deployment of these applications actually happen onto the edge. I mean, there is a lot of deployment, that happens, in the cloud as well. But to a large extent, when you go back and talk about the enterprises, when you go back and talk about healthcare or financial verticals, there is a lot of these deployment happens on the edge. So the whole the environment that we have to create for any AI developer or any person who is actually kind of enabling AI applications for any of these verticals, it becomes very important for us to create a cloud native environment. What I mean by that is basically, have a similar development and deployment environment both in the cloud and on the edge. So that is, for if you're developing a particular, if you're solving a specific problem, say, let's just take autonomous vehicles or ADAS systems in a car or whatever, right? So if you have to go enable some of those applications and develop that software in the cloud, you need to basically have a similar kind of, not identical, but a similar kind of software development environment in the cloud, right? So that's where the democratization comes in, because you kind of like give access to as many software developers as possible, the same access to the same environment that the person wants or needs to develop software. So it's a challenge, but there's a lot of effort across the industry being put in this. And I'm kind of like, at some point you even hear about digital twins, right? Digital twins of physical infrastructure being made available in the cloud for better application development and software development, on those digital twins, which can then be kind of like enabled on the physical infrastructure as easily as possible, as seamlessly as possible, right? So I think yeah, I mean, you're absolutely right. It's you need those capabilities in the cloud. You need to make those capabilities as accessible and available as possible to as many developers as possible. So I think that's key.
Collaboration and scaling. Okay, you will not be able to scale, right, anything across your multiple instances, right, unless again larger amount of developers. It's not even data scientists, it's not even AI specialists, right? This is broad set of engineers, all right? And we're touching my favorite topic here, the talent, meaning the roles, okay? Because everyone seemed to be thinking that only C-level executives making those decisions, okay, in terms of what technology to acquire, what vendor to select, all right? Can you please shed some light how those roles are colliding and changing from CTOs, CIOs to architects, right, to principal architects, to these groups of, right, different talent, engineers, developers, how this complex world is working now?
Yeah, I mean, so let's talk about the C-suite and the architects in a second. But if you think about it, Irene, I mean, there's massive explosion of innovation these days, right? I mean, you have so many companies who are actually kind of enabling fantastic applications on AI using the infrastructure that's available to them. I mean, you can, there's so many AI companies and that in the last, say, 2 to 3 years have kind of like enabled like some really, really cool applications. And that's possible because because of the infrastructure that we have. And I think it's, be it large companies and just pushing your analogy a bit into large companies and small companies. I specifically don't believe that innovation is now kind of limited to large companies with deep pockets, right? So you have smaller companies with a reasonable amount of investments or financial capital to kind of enable some really cool applications. So, and that's the whole point of democratizing, right? And end of the day, you really have to kind of like make, from our standpoint, right, you need to be able to make the technology available, right, to as broad set of customers as possible, right? And like I said, it could be, that's why I established that on one side you have these hyperscalers and cloud service providers and all of them. And on the other hand, you basically have academia, you have enterprises, and all of them trying to solve their own problems, specifically when it comes to process productivity improvement or whatever, right? So hence it's important for technology companies to make all of the assets available. And even going back to the decision making and the question that you asked, I think again there is no boundary. I don't really kind of like see, okay, it's really kind of a CTO of an organization or a whatever C-suite title you can actually pick is actually making, decision making is very widespread now when it comes to technology development. I mean, there are still a lot of decision making that's kind of like that happens at the higher levels, but when it comes to technology and innovation, I think it's it's exploded. I mean, it's fascinating, to be really honest. I mean, it's wonderful to see so many new things coming out. I mean, of course, there is always this thing, and I keep people keep asking me this question about what happens. I mean, are people going to use AI for unintended purposes? Is this going to be like doomsday situation and stuff like that? I mean, I think I personally don't believe in that, because I mean, again, any technology, when the computers came in late 80s, I believe, it's I mean, everybody thought, okay, it's not, it may not be the right thing. And then smartphones, for example, in 2010, 2000s, and then you have AI. I think again, we will learn to use and make sure that we use AI for the right reasons. There will be, I mean, I'm pretty sure these questions are valued, by the way, right? The questions are very valued. We have to make sure that AI ethics and AI is actually used for good purposes, right? But there needs to be checks and balances put in place. But overall, I believe it's a great thing. It's fascinating. It's
Absolutely. Awesome. And it's here to stay, okay, like it or not. So our jobs at every level, right, is to make it accessible and to make it, to enhance our abilities, right, to make us better, living longer and healthy lives, hopefully, right?
Exactly.
Suraj, you mentioned fourth gen Intel Xeon scalable processors before. Okay, why don't we come back to that? Because it's important to highlight, right? And my interest is in the top industry verticals, okay? Where do you think businesses will realize the most outcomes with the new processors available?
Yeah, so one key thing that I want to touch upon, again, from industry perspective, right? Again, Intel Xeon processors have been around for a long time, right? And as the general purpose compute that it brings in. But as I said earlier, the fourth gen basically has specific accelerators for AI, right? For vector and matrix computation. So the key thing that I want to stress upon here is, for any enterprise, be it healthcare, financial, automotive, or industrial, if they want a platform that can actually do, for example, I mean, depending on their workload, and if they are not really kind of like churning large scale models and stuff like that, they can actually deploy Xeon based systems which can actually handle data prep. And Xeon has been, and CPUs in general, general purpose computers in general, have been kind of handling all of the data prep up until now, right? And that's going to continue. So the Xeon-based platform can handle data prep, going back to the pipeline that I mentioned, right? It can actually do small-scale training, fine-tuning, and all of the training that's actually needed for them, right? And then you have the inference part of it. So specifically, I think it's across all of these industries, and to a large extent, they already have Xeon-based software infrastructure. They already have the tools that they have been using, right? So if you really think about total cost of ownership, if you really think about cost to migrate to another new compute infrastructure versus staying on Xeon and augmenting and enabling more training capabilities and AI capabilities, that's the 4th Gen Xeon for you. So I mean, we are super proud about this product, right? And its capabilities across multiple, both from a use case perspective and from an overall, the far reach that it has across the industry. So yeah, I mean, I think it's again, this is just the beginning. It's going to be fun.
Fantastic. We encourage everyone to check this out. All right. We encourage everyone to look at multiple resources available, of course, Intel dominating the market. And let's make sure that, again, the awareness is there. And Suraj, thank you so very much for this session today, because this helps. Which definitely helps. Yep. Before we conclude, can we possibly leave audience with few takeaways? Okay, we covered a lot, right? We went deep and we went broad. So few takeaways maybe to remember this episode by.
Yeah, I mean, I think again, to lead with like I just the last point that I made. I mean, unless you're really running dedicated large-scale AI workloads, I mean, you can actually kind of use the Xeon platforms, the 4th Gen Xeon platforms for majority of your tasks with covering data prep, model optimization, model training, and inference. And one thing that I mentioned, it's as important as the hardware. It's basically the software infrastructure as well, right? So it's kind of it's more about us enabling the right tool sets, the software environment for any AI developers to kind of like enable. So that's it's an entire end-to-end platform that we have to focus when we actually think about, okay, what problem are we trying to solve for AI? And yeah, I mean, in general, it's an ecosystem effort, Irene, and this is what it is, right? It's just not one company trying to kind of like build everything, right? I mean, AI, I believe, can scale when it's a broad ecosystem play, right? When the platforms and the environments are as flexible and open as possible for different parties to bring in their goodness, and I hope that's what continues, and we kind of like use AI for all the right purposes. So that's it.
Wonderful. Thank you, Suraj, so very much. Thank you.
Thank you, Ari. Thanks.